Binomial products. Bi, of course, meaning two. Nomial meaning terms, I guess. Polynomial, many terms. And products. So we're going to multiply a binomial with a binomial. Something with two terms with something with two terms. Probably the first time you did this, they told you about good old FOIL. Yeah, first outside, inside, last. That sort of idea. Or maybe FACE. You know the FACE method? Oh, watch and learn. It's similar to FOIL, but I draw the line in. Because watch, first, x times x. Outside, x times 1. Inside, 6 times x. Last, 6 times 1. Now look, I've got a face. See? There's the chin, there's the nose, ears, and the eyebrows. You end up with the face. The face method. Okay. X squared plus 7x plus 6 is our answer. Alright. But of course, we like to save time in maths. Anytime there's a pattern, brilliant, saves us time. And maths, in a way, is the science of patterns. We don't want to do the same thing every single time. So we know that a plus b all squared turns out to be a squared plus 2ab plus b squared every time. A minus b squared, similar. A squared minus 2ab plus b squared every single time. In general, oh, did you know that? It doesn't matter how many pronumerals you got, that pattern exists. A plus B plus C plus however many you want squared will always be each one of those terms squared plus twice every possible pairing that you can have with all the pronumerals. So when we only had two there, the A and the B, there was only one possibility, 2AB. But if I had had a plus b plus c all squared, I would have been a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. All the possible pairings. Okay? So that pattern is always there. And difference of two squares, a squared minus b squared. Okay, so, challenging. X plus 2 squared. There it is. Now, I'm not saying you would write this, by the way, but that's what we're thinking, of course. I would hope at this stage we can go bang straight to our answer. But just in case, remember what we're saying is, that's a plus b all squared, so that's a squared. Okay, good A. Oh yeah, 2ab. Oh, that's b squared. Fantastic. Put it all together and get an answer. 3x minus 4 squared, in reality what we do is just go, bingo, there's the answer. Just be careful with your multiplication. Difference of two squares, first one squared minus the second one squared. So you remember your formulas and it just makes life so much easier. Here's a binomial with a trinomial. Now this is one where I might tend to draw the lines in just to make sure I get every possibility. If I've got 2 terms in the first one, 3 terms in the second one, then when I expand out, I should end up with 6 terms. So that's what I'm expecting. If I don't get 6, then I know I've made a mistake and I can go and check which one have I missed. So a times a squared, then you go, yep, all right, there's a times everything. Now let's go, brilliant. I've got 6 terms. Now I'll just tidy everything up. And there it is. There's our answer. A cubed minus a squared plus a plus 14. Have you ever seen the method of detached coefficients? Quite possibly not. I found it in a textbook that was first published in 18... something or other. But here's how it works. See, I've got a trinomial times a trinomial. List all the coefficients of the first factor. Start with the highest power. But once I've started with cubed, I need a number for every power. So I have the 0 there. The second one, doesn't matter if this one starts with squared rather than cubed. Start with the first number and keep going. So now the first one's 3 because 3x squared is the first one. Then 4, then minus 2. Okay. Multiply all of the first row by the first number in the second row and then write that result under the first number. Okay? So, do that again. All of the numbers by 3. So 3 times 2 is 6. 3 times minus 4 is minus 12. 3 times 0 is 0. 3 times minus 5 is minus 15. Now, do the same thing but with the second number but you write the first result under the second number. So we get 8 minus 16, 0, minus 20, we've sort of now created another column over there. I'm multiplying every number by the second number. 4 2s are 8. 4 times minus 4 is minus 16. 4 times 0 is 0. 4 times minus 5. Now, guess what we're going to do now? Right, we do the third one, but now we position it under the third number. So all of the numbers times minus 2. And so, yeah? You just add down the columns. 6 minus 4 minus 20 minus 7 minus 20, 10. You now have your answer. But the coefficients have been detached. So now you rewrite the coefficients of the answers starting with the highest power. Now the highest power has to be for this one 5. Highest power equals the highest power times the highest power. There's your answer. Voila. So if I did it this one, I'd go, I'm going to write the quadratic out first. 1 minus 3 is 7. The next one's 1, 2. Multiply by 1. Multiply by 2. Add down the columns. There's my answer. The highest power is 3. So it's a cubed minus a squared plus a plus 14. There's the answer. It can actually be quite efficient. Something like this. Okay, again, I'll just write the coefficients. 3, 2, 0. You notice you need a term for all of the x's. Don't worry about what the y's are doing there. And then, same idea. All of it by 2. All of it by 0. Well, I'm not going to bother writing that down. All of it by minus 1. But remember, there was a row that was starting with 0. So it's the third number under the third number. There's our answer. Ooh. Voila. So the highest power is going to be x to the 6. What's happening is powers of x are going down by 1, powers of y are going up by 1. The two powers are always adding up to be 6. There's the answer to that expansion. All right, there's 1b